Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 11, more about similar triangles. So we're starting off with an exercise. And it says, in the diagram below, you have triangle ABC, which is right here. It's the darker shade. No, it's not. It's the larger one, BC. ABC is the big triangle. And then we have triangle A, B prime, C prime. Now, when you look at this, you might think, oh, they made a misprint. That should be A prime, B prime, C prime. But if you look, and we put a triangle right here, and this right here is triangle A, B prime, C. The triangles are sitting on top of each other here, and the center of dilation is the actual vertex A. So A in both triangles is the same. So A is here, A is here. So this triangle is sitting on top of the other triangle since the center of dilation is the vertex A. So that is not a misprint. It is triangle A, B prime, C prime. So we already know that angle A is congruent to itself. Okay, so I can already say that the measure of angle A is congruent or equal to, the measure of angle A is equal to the measure of angle A. Okay, that's kind of obvious, right? So if it's 30 degrees, then it's 30 degrees. Okay. Now, from this, it says A, based on the information given, is this big triangle similar to this little triangle? And explain. So in order for us to have similarity, we need two angles that are congruent. Well, I know the measure of angle A is equal or congruent to the measure of, or angle A is congruent to the measure of angle A. Actually, I wouldn't use that congruent symbol there. Measure of angle A equals the measure of angle A, or angle A is congruent to angle A. So we need two triangles that have the same angle measure. Now I have B here, I don't know its measure. I have B prime here, I don't know its measure. I have C up here, they did not tell us what that measure is, and C prime down here, they did not tell us what that measure is. So I cannot use the angle theorem to prove these two triangles are similar. So how else can we prove triangles similar? Well, if our sides are proportional. So we want to find a common ratio between all three sides. So if I say R equals, and I'm scaling down, my original pre-image is ABC. So if I'm scaling down, then I want my larger triangle in the bottom, so my fraction is going to be less than 1. So I'm going to put the length of CB. And on top, they have the length of C prime, B prime. And these absolute values are not necessary, but it's okay to use them. And so I'm going to put C prime, B prime is 2. It says it right here. And CB is 8, so I'm going to put 2 over 8, and I'm going to reduce that. So the ratio is 1/4. This little triangle is 1/4 the size of this triangle, or can I even say that? Well, all I can say right now is BC and C prime B prime. C prime B prime is 1/4 the length of CB. Now I'm going to look to see if I can find A B prime. So now I need to know what A B prime is with respect to A B. So A B prime equals 2.7, and A B, I don't know it. And then finally, I need to do the same for the length of A C prime divided by the length of AC. And AC prime, I do not know. And the length of AC is 6. Now, just because this is 1/4, we can't just assume that they're all going to be a fourth. I cannot multiply this by 4 and put a number down here and say that's how long this is. And I can't put a number up here so that that number divided by 6 is 1/4. That is just making assumptions, and that does not prove anything. So, based on the information given, are these triangles similar? Don't know. Not enough information. Okay? We need more information to determine that, so it cannot be determined. Okay, B. Assume the line containing BC is parallel. So let me get some of this stuff out of the way here. Assuming that BC is parallel to B prime C prime. So this is parallel to that. With this information, can we now say that they are similar and explain? Well, let me get my ruler here so I can draw straighter lines. And I'm going to just highlight what they're talking about here. So here is BC. And here is B prime, C prime. So there's two line segments. Now, if I put my ruler here and rotate this down here, and let's use purple this time, and I draw a line segment here, okay? Well, this is a parallel line. This is a parallel line. And if these sides extended beyond, they were lines, a line crossing two other lines is called a transversal. This is a transversal. And since my two lines are parallel, then I know that this angle is congruent to that angle because they're corresponding angles. So now I can say the measure of angle A equals the measure of angle A. That's this angle congruent to itself. And now I can say the measure of angle B is equal to the measure of angle B prime. Because of this transversal, these are corresponding angles, and corresponding angles are congruent. So therefore, now I can conclude that, yes, indeed, triangle A, B, C is similar to triangle A, B prime, C prime, because of angle theorem. Okay? I just explained that. I didn't write everything out, but if you were to answer that, you should write out your thoughts. Explain the transversal and the corresponding angles. Now it says given triangle ABC is similar. Now we know the triangles are similar. Now they're saying, okay, now that we know they are similar, what is the length of AC prime? So all I'm going to do here is use this right here. So if I take AC prime, it has to, I don't like question marks, let's make it a variable. I want to solve for x. And I know that has to be equal to my common ratio of 1/4. So if x over 6 equals 1/4, then I can solve to find out what x is to make this true. And we cross multiply. So 4 times x equals 6 times 1. 4x equals 6. Divide both sides by 4. That cancels. X equals 6/4, which reduces to 3/2. So the length of, the length of AC. So now I would say AC prime. Let me do that again. AC prime, the length equals 1 1/2, or 3/2. That's this side right here. Now it says given that triangle ABC is similar to A, B prime, C prime, determine the length of side AB. Now all I need to do is use this equation. Okay, I'm trying to find that question mark here. Let's change that to an x now. So if I put x there, and I remember that my ratio is 1/4, so I set that equal to 1/4. So when I cross multiply, x times 1 equals 4 times 2.7. 1 times x is x. 7 times 4 is 28. Carry that 2. 4 times 2 is 8. Plus 2 is 10. Don't forget your decimal. So if AB is 2.7, then the length of AB prime, I'm sorry, AB, the whole thing, equals 10.8. Okay, number 2. In the diagram below, you have triangle ABC, which is here, and triangle A prime, B prime, C prime, which is over here. Use the information to answer parts A through C. So let me scroll this up here. And A says, based on the information given, are the two triangles similar? So I'm going to look here, and I see that A prime and A are both 59 degrees. So I would say the measure of angle A equals 59 degrees, and that is also equal to the measure of angle A prime. So now I know the measure of angle A is equal to the measure of angle A prime by the transitive property. Now I'm going to look at B. B is here, it's 92 degrees. B prime is here, it's 92 degrees. So I would say the measure of angle B equals 92 degrees, which equals the measure of angle B prime. Transitive property now says the measure of angle B is equal to the measure of angle B prime. So I have two angles, so I can say, therefore, triangle ABC is similar to triangle A prime, B prime, C prime by the angle-angle theorem. Okay. Part B. Given that the triangles are similar, determine the length of A prime, C prime. So I need to find a common ratio. So I look at sides I know. Here's AB. Here's A prime, B prime. So R is going to equal my image, A prime, B prime, divided by my pre-image, length AB. Substitute and put 5.12 divided by 3.2. Okay, got my calculator out for this to save time. 5.12 divided by 3.2 equals 1.6. So this equals 1.6. So that's R. R is 1.6. Now that I know my common ratio, I now find the side I'm looking for. Now they want us to solve for A prime, C prime. So I would say A prime, C prime divided by AC has to equal 1.6. Now I could do it by decimal, or I could do it by fraction and cross multiply. It doesn't matter. A prime, C prime. Okay, so I don't know it. That's right there. So that's my unknown. So now I'm going to substitute in. So I don't know A prime, C prime. AC is right here, 6.1. Equals 1.6. In order to solve for x, we multiply both sides by 6.1. So when I multiply 6.1 and then divide 6.1, they cancel. And I get x equals 1.6 times 6.1. And it is 9.76. So it says x, but really what it is A prime, C prime. So A prime, C prime equals, the length of A prime, C prime equals 9.76. C, looking for the side length of BC. I know my ratio is 1.6. I want BC, so I write the length of B prime, C prime over the length of BC equals 1.6. I look, see what I know. BC is blank. B prime C prime is 8.96. So I'm going to write 8.96 divided by my unknown BC equals 1.6. Okay. Okay, so in order to solve this, I'm going to show you a trick here. I wanted to get x by itself, and we don't want it in the denominator, so I'd multiply both sides by x. This will cancel. So I get 8.96 equals 1.6x. Now I need to get 1.6 away from x, and since it's multiplication, we have to divide by 1.6. Now if you notice something, if we go back to the original here, what happened was my numerator that's over the variable just simply moved over and became the numerator over my 1.6 on this side to give me 8.96 over 1.6. That was a two-step process. Multiply by x and then multiply by 1.6. But once we get the hang of these patterns and we see that, then we can simply use our shortcut, and all we have to do is take this fraction top piece and move it over here, and that will be my x. And when I do that, 8.96 divided by 1.6 is 5.6, and that is BC. Okay. Exercise 3. In the diagram below, you have a triangle ABC. You have a triangle A prime, B prime, C prime. Use the information to answer the question below. Okay. Based on the information given, is this similar to this? So, first thing I would check, do I have two angles that are congruent? Well, I've got the measure of angle B equals 101 degrees, and the measure of angle B prime equals 101 degrees. So the measure of angle B prime, I should have written that, the measure of angle B prime. So by transitive property, the measure of BB is equal to the measure of B prime. So far so good. But for angle, I need two angles. I look at A, no information. A prime, no information. C, no information. C prime, no information. I cannot use AA to prove this. I then need to use the proportionality of sides. So I need to find a common ratio between two sides. So I take BC, compare it to B prime, C prime. So that's going to be my R. R equals the length of BC divided by the length. Actually, I should put B prime, C prime on top. And the reason I do that is because my image is always my numerator and my pre-image is my denominator, and that will tell us if it was scaled up or down. So my B prime, C prime is 11.66, and my BC is 4.6. So when I plug that in the calculator, 11.66 divided by 4.6 is let's go out two decimal places, 2.54. Okay, so now I'm going to do the same for the two other sides that I know, which is A prime, B prime, and AB. So now I'm going to write R equals A prime, B prime divided by the length of AB, which equals A prime, B prime is 10.58, and AB is 5.3. So then I need to put that in my calculator. 10.58 divided by 5.3, enter, and I got 2.53 the first time and 1.99 or 2.0, and I round it the second. Well, these are not equal, so based on the information given, no. I could just say triangle A, B, C is not similar to triangle A prime, B prime, C prime, because I do not have a common ratio of proportionality of sides. Okay, that is the end of lesson 11. Review the summary and go do your problem set.